Now, so first we start with the simple problem. Okay, and these are very common problems. Now, although it's a simple problem, but it's a very common problem, which in many undergraduate exams you'll have this. So, a man who is heterozygote for B blood. Now you understand what is an heterozygote for the B blood. Is married to a woman with type O blood. Okay, what blood type will their children have? Okay, so when you get a problem like this, you have to analyze step by step. You have to do a step-by-step dissection of this problem and understand what's going on. So here's the man and the woman. Now we know that the man is heterozygote for the B blood type. Okay, so we know that he's not a homozygous, so he doesn't have IB, and neither he can have IB, IA because they are codominant alleles, right? If you have IB with IA, you will have AB blood type, but the man has a B blood type and the man is heterozygote. So that information is sufficient for you to come to the conclusion about the genotype of this man, and that is IB and small I. He is heterozygous for the blood type B. Now, this person is married to a woman who has a type O. Now, we know that O is a recessive allele, right? So that means the woman has to have two small I, or alleles expressing the O blood type. So now we have figured out the genotype. Now we will move on to making the cross. Okay, and so we have the Punnett square, and the rule is on the left side you write the man's or the male genotype, and on the top in the horizontal line you write the woman's genotype. So you can understand. So basically the man has two alleles, IB and I, and the woman has two alleles, basically the same alleles. She is homozygous for the O type. So first you draw those alleles and then you make a cross. So IB with I, that's going to give rise to a child with B blood type. And again, IB with I will give rise to a B blood type. II will give rise to a O blood type child, and II will again give rise to a O blood type child. Okay, so if they cross, if they mate, these are the different possibilities of children they will have. So 50% of their children will have B blood type, and remember, all of the B blood types will be heterozygous. They will never have a homozygote B blood type child. And 50% will have homozygous O blood type. O can only be a homozygote state. You can never have a heterozygote O because O is a recessive allele. Okay. Moving on to the next problem, which is a little bit complicated. Here, a man with AB blood is married to a woman with A blood. Okay. And the woman's mother had O blood type. Okay, what blood types will their children be, and in what proportion? Okay, so again, the moment you see a problem like that, start analyzing. The man is with the AB blood type. Okay, so again, there's the man and the woman. Now we know that it's a codominant allele, right? So the man with the AB means it's very easy to figure out. So that's the man's AB blood type. So it's very easy to figure out that this person will have IA and IB. There can be no other combination because these two alleles are codominant, right? So it's easy to figure out the man's blood type. The question is, so that arrow is the man's genotype. The woman with A blood type, that's one hint. Hint number two, the woman's mother had O blood type. So is the woman homozygote for the A allele, or is she heterozygous? Okay. Now the moment you see a problem like this with the woman with the A blood type and the mother or the father has O blood type, you can 100% come to the conclusion that she cannot be a homozygous for the A blood type. She has to be an heterozygous. So that is going to be the woman's genotype. How did I come to this conclusion? I will show you. So we just now select the woman, and let's find out, let's go back, okay, to her parents, and how can she have a heterozygous IAI IAI genotype. Okay, so in the black and white, it's shown her appearance. We talk about past. So we have given a black and white picture. Now, we know that the woman's mother is O. So now we can talk about the woman's parents' genotype, and so the woman's father, can be either homozygote for A, because she has A, right? So her dad has to have A blood type, right? So the dad can be either a homozygote for the A alleles, or he can be a heterozygote. Okay, but we know the woman's mother, is O blood type, so she has this two small I alleles, or the O type alleles. Now let's see if these two people, her parents, when they cross, what kind of child with what type of genotypes they will have. So first we will cross if the father would have been a homozygote for A, and then what kind of cross will result. So we have the Punnett square here, cross number 1, and I'm not going to explain anymore. So you write the man's genotype on the left hand side and the woman's on the top, and then these are the different combinations. So you see that if the man would have been a homozygote for A, then every child would have been heterozygote for the blood group A, and they can never have any other blood type children. Okay, if however the father would have been heterozygous, and then cross 2. So again, we have on the left side the father's genotype. The mother is II because she is O. So these are the different combinations of different types of children with different types of blood group they would have had. So so you can see that in the second cross, they would have had, if the father is heterozygote, then they can also have O blood type children. But we know that this woman is this woman in the original cross, which is given in the problem, she has an A blood type. So she has to be an heterozygote. There is no possibility that she will have a homozygote AA genotype because of her appearance, because her mother has an O blood type. Okay, so so that comes back to the original cross, where the woman is a heterozygote. Okay, so now here I've explained in this lecture, but when you get this in the exam, just know that if you get a problem like this, when a woman has an A blood type with the mother O, there is 100% certain that she will be an heterozygote. She cannot be a homozygote coming from a O mother. Okay, now let's get back to the problem. With a man with the blood AB blood is married to a woman with the A blood, and the woman's mother had O blood group. What blood type will the children have? So now we know that the man's genotype is IAIB, and we just figured out that the woman's genotype has to be an heterozygous for A. So now it's simple. Just make the Punnett square, write the man's genotype on the left hand side, the vertical line, and the woman's genotype on the horizontal line, and then just make the cross. So they can have children with a homozygote for A blood group. They can have children with heterozygote who is heterozygous for the A blood group. They can have IAIB, that's an AB blood group codominant child, and they can also have an heterozygote blood group B child. So proportion 50% of their child will be having A blood group. Okay, and 25% of their child will have AB blood group, and 25% possibility that they can have a child with a B blood group. Okay, so now next move to claim problems. Okay, claim problem means a woman is claiming a certain person is the father of her child. Okay, is her claim true? Is there logic in her claim? Can you I mean, whatever she's claiming, is it true or not? So these kind of claim problems. So here, a woman with the blood type A is claiming that a man with the blood type AB is the father of her child, who is also type AB. So the child's genotype, a child's blood group is AB. So could this man be the father? Show the possible crosses. Remember that the woman can have AO and AA. So the problem says the woman has A. It doesn't say if she's a homozygous or heterozygous. Okay. So again, this is the man and the woman, and this man, the woman is claiming that man is the father of her child, and we know that the man's blood type is AB. So it's very easy to come to the genotype because a blood type AB will only come from a genotype AB. The woman can be either homozygous for the A because she is an A blood type, or she can be heterozygous. Now we will do both the crosses and we will try to figure out if this woman's claim is right or wrong. Okay, and again, so the problem says that they have a child, a girl or a boy, with the AB blood type. Okay, so the child has AB. Okay, the woman has A. We don't know if the woman is homozygous for A or heterozygous. She's claiming this man with AB blood type is the father of her children. Okay, of her child. So let's find out. So first we'll do the first cross where we consider the woman as a homozygote for A, and it's the cross 1. Okay, so on the left hand side we have the man's genotype, this man whom she claims to be the father, and then we have the homozygote A woman, if we consider the woman to be homozygote. So these are the possibilities. We will get A blood type homozygote. We have another A child homozygote. There is an AB possibility. You see now the IA and IB, they combine, and then we get an AB blood type, and we have another AB blood type. So basically 50%, if the woman is homozygous for the IA allele, then 50% of the children will have A blood type and 50% of the children will have AB. So this man from the cross 1, yes, he can be the father of the child. If the woman is, however, a heterozygote for the A, then let's do the cross, and this is cross 2, and you can see that again the man's genotype on the left side, IA and IB alleles, and the woman then in this case will have an IA and a small I, that is the blood type O allele. So in this cross they can have a child who is homozygous for the A, so that means in other words A blood type child, another A blood type child because I is a recessive allele, right? But so they can have a child who is heterozygous, and even in this cross, you see the IA and IB will combine, and they can have a child with AB blood type, and they can also have a child with the B blood type because IB will match with small I, and since small I allele or the type O allele is recessive, it will give rise to the B blood type. So 50% of the crosses, if the woman is heterozygous for A, will be A blood type, 25% chance of AB blood type child, and 25% chance of the B blood type. So in other words, yes, the woman's claim is logical. This man with the AB blood type it can be the father of her child. Now, the same problem can be given in a different way, in which the woman blood type is A and she's claiming that the man with the O blood type is the father, okay, and the child has an AB. So the same problem, just we change the man's blood type from AB to O. Can this man be, who has an O blood type, can he be the father of a child? Can he be the father of a child with AB blood type? So again, since the man has an O blood type, it's an easy thing. His genotype is II, small I, and we see that the woman again has the same problem. She can be a homozygote or a heterozygote, and we will take both the possibilities, and we'll do the crosses, two Punnett square, to find out if this man, with the man who is homozygous for O, or in other words is O blood type, can he be the father of a child who is AB? Again, the child, girl or boy, has an AB blood type. So the first cross, if the woman is homozygous for A, cross 1. So you can see that the man's genotype on this side, the woman's genotype on the top, and these are the possible combinations. Okay, you see that since the man is O, every child, 100% of child will have A blood group. Okay, so there is no AB. If the woman is homozygote for A, there is no way this man can be the father of a AB blood group child. Every child born from this cross will have A blood type, no AB. If the woman is a heterozygote for the A allele, let's see what happens. The cross 2. So again, the man's genotype on the left-hand side. The woman is heterozygote now for the A allele. So the first cross is going to be a heterozygote A blood type A. This is an O because the II, they're crossing, so they can have a child with O blood group. Again, when you cross this in this box, you'll have a child with the A blood type, heterozygote. And again, the last box will have O. So 50% will have A blood and 50% will have O blood type. So this man, in every possible way of cross, a man who is O blood type cannot be the father of a child with AB blood type when the mother has an A. Okay, so if the man has O blood type, then the woman's claim is false. Okay, so I hope I was able to help you understand the concepts. Now these problems are the basis of any kind of problems you will get on blood type. I think if you follow my lecture, you will be able to answer any kinds of blood type genetics based questions. Okay, and bye bye and all the best. Thank you.